So this is the basic trigonometric functions which you have to know for the basic trigonometric angles. So
Right.
what are the functions of trigonometry? Sine, cos, and tan. If you know for these three functions, the rest of the things you'll be able to find out easily, right? For the
Right.
entire circular range. So what is the value of sine 0?
Sine 0 is 0.
0. And sine 30?
1 over 2.
Good. Sine 45?
Root 2 over 2.
Good. Sine 60?
Root 3 over 2.
Very good. Sine 90?
1.
1. Very good. Can you tell me the angles of trigonometric values of cos?
So it's
Cos
1.
0?
1.
Mm-hmm.
Root 3 over
Yeah.
2. Root 2
Mm-hmm.
over 2.
Mm-hmm.
1 over 2.
Mm-hmm.
And 0.
Very good. And tan 0?
It's undefined.
No. Tan 0 is 0 by 1 is
Yeah,
0.
this is undefined. Isn't it undefined?
No, no. No, no. This is not undefined. This value is
Oh.
0.
Oh,
Yeah.
okay.
Whereas tan 90 is undefined. Anything divided
Oh,
by 0 is cannot be defined. It is infinity. So
okay.
1 by 0 is infinity and undefined. Yeah. So tan 30?
Tan 30 would be 1. Wait, it would be root 3 over 3, right? Because, like, if you
Root 3 over
rationalize.
3. Yeah.
Yeah.
Yeah. Root 3 over 3 or 1 by root 3. Anything is fine.
Yeah. And 45 would be 1.
Very good.
This would be root 3.
Mm-hmm. Good. So these are the basic trigonometric functions which always have to remember. And if you know these things, you'll be able to find out the trigonometric functions for any angles which is given within the circle. So what
Right.
is the total angle of the circle? How much degrees does it cover?
360. 360.
Yeah, 360 degrees. Yeah. Is it easy for you to remember all the values in all the four quadrants? See, if suppose you're having almost 1, 2, 3, 4, 5, 5 into 3 values in just the first quadrant.
Yeah.
So that is almost total 15 values.
Right.
And if you consider this as quadrant 2, quadrant 3, quadrant 4, you'll be repeating the same values again, right? In 2, 3, and 4, 2. And so you'll be ending up in getting how many values in total?
60.
60 values. 60 values is hard to remember and memorize, and that's not the way to be done, right?
Yeah.
So let's find a better approach in which you'll be able to remember all the values and in a proper way. And actually, it won't be 60 values, it will be slightly lesser because here you're considering in first quadrant 0 and 90 degrees. So again, in second quadrant, if you're considering 90 and 180, so you're considering 90 twice, right? So mostly it will
Yeah.
be 60 minus 2, 58 values. So
Okay.
even though if it's 58 is also huge, it's huge. So we need not remember in such a way. Okay, let's find out the way. You consider this circle, and as I told you about the quadrants, this is the first quadrant, this is second quadrant, third quadrant, and fourth quadrant. Okay. So as we know that in the first quadrant, everything is positive. So I will write it as all. Okay. So everything is positive in the first quadrant.
Mm-hmm.
Whereas in the second quadrant, only the sine function is positive. Sine is positive. And third quadrant, tan is positive. And fourth quadrant, cosine is positive. Okay. If you want to know like how these things are positive, only in sine is positive in second quadrant and tan is positive in third quadrant, we'll be seeing that now. Okay. So if you
Okay.
consider this particular circle, and it has its origin at the center. Consider it as O. So let us write the circle separately, like an enlarged portion. I'll be writing it here without the
Mm-hmm.
circle intact, right?
Okay. Right.
So if I want to consider See, trigonometric functions are always considered for triangles, right?
Right.
Triangle. Let me draw a triangle here also. Let's consider the base of the triangle to be 3 and perpendicular to be 4. And what would be the hypotenuse?
5.
Perfect. Similarly, for the triangle in the second quadrant also, should we do the same?
Yeah, that would be -3 this time, right?
Okay.
Wouldn't it be -3?
Yeah, -3.
Oh, it's just the same value now.
And this one, it is positive. And this is also positive 5, right?
Yeah.
So, if you want to consider in the first quadrant, any function you take, see, you notice that everything is positive, right? 5,
Right.
4, 3, everything is positive. So, whatever you divide, both positive numerator and positive denominator, so you end up in getting, in quadrant 1, everything is positive. Correct?
Right. Correct.
But whereas if you take the second quadrant, so for sine function, so you tell me what is the value, like what is in the positive? For sine function, you have the numerator positive. See, sine is nothing but perpendicular by hypotenuse. You have this angle here, so sine is perpendicular by hypotenuse.
Right.
Perpendicular is 4, it is also positive. And
Right.
hypotenuse is also positive.
Right.
Whereas in cos, what happens? Cos
Cos is
base adjacent
on which side are we talking about?
for the quadrant 2.
Quadrant 2. It will be cos being. Wait. I don't understand what you're trying to say. That would be positive or positive.
Yeah. See, what is the this one formula for sine of sine theta?
Sine
theta is nothing but opposite by hypotenuse.
Oh, right. Okay, I understand. Okay, so this would be.
So it is plus 4 by I didn't want to write the values because I am not here concerned about the values. It's mainly we are looking each other the sign side.
Okay, so it would be negative over positive, right?
Negative over positive, that means it is a negative, right?
Yeah.
Similarly for tan, what happens?
It would be a positive over negative, so it's a negative.
Negative, right?
Yeah.
So here it is positive. So let us consider for the case of the other two quadrants also. So what happens then?
Okay, so quadrant 3, sine would be negative, cos would be negative, and tangent would be positive. And quadrant 4, sine would be negative, cos would be positive, and tangent would be negative.
Third quadrant and fourth quadrant. So what happens for third quadrant? As you said, sine is opposite by hypotenuse. Negative over positive, correct?
Yeah.
So that is negative.
Cos is also negative
So
positive.
cos is also negative over positive. Okay, that is also negative. Now here tan.
Tan would be a negative over negative, which is positive.
Very good. So what about the fourth quadrant?
Fourth quadrant would be negative over positive, which gives you negative.
Very good.
And
very good.
Cos would be positive over positive, which would give you positive.
Very good.
And tangent would be negative over positive, which is negative.
Very good. So here you got to know the reason behind why these things are positive in which quadrants respectively, right?
Mm-hmm.
So all the angles are positive in the first quadrant, only sine is positive in the second quadrant, and in third quadrant tan is positive, and fourth quadrant C is positive. So
Right.
instead of each time remembering like this or making it as a long process, we'll simply write it in a simplified short form. Is this okay?
Yeah.
Shall we write like this in further problems, further boards?
Yeah.
Okay. So as we discussed now, we have this like this. So A, S, T, and C. So quadrant 1, 2, 3, 4. Even if you are like going to make some small mistakes here, then the entire problem is going to be wrong. You should be very cautious of it, right?
Right. Right.
Okay. So if you want to write the degrees, so always it is like you have to go in the anti-clockwise direction because that is the way we have been doing it all this while, and the angles have been designed for that, right? Trigonometric values have been suited to adapt to
Right.
it. So
Right.
do you which one are you familiar with? Are you familiar with the angles or the radians?
Familiar with the angles.
Okay. However, I'll write both because I want you to learn from both the ways. So if you want to consider this particular value, how much it will be? 90 degrees or pi by 2, right?
Right.
Pi by 2 radians. So what
Yep.
would this be?
That would be
This part?
180.
Okay.
180 and would be pi, right? Pi,
Pi radians.
pi radians, yeah.
Pi radians. Yeah, very good. So this one would be
That would be 270 and 3 pi over 2, right?
3 pi by 2. Very good. So this would be
360 or 0.
very
So it
good.
would be 0 or 2 pi.
Very good. So this is how it is going to be. But if you are asked to find, see now you know the basic everything within the first quadrant you are very familiar with and you have no doubts at all, right? So if you are asked to do, if you are required to find out sine of angle 120, see this is your main line, okay? So whenever you're going, this is like your equator kind of line, above this and below. So you should not consider this particular 90-degree line. 90 to 70 line is like a secondary line. 180 to 0 is the primary line because that is the base with which the angles have been created and formed, right? Perfect.
Right.
Yeah, so if you want to go to sine 120, so how do you make it a sine 120? So which is the angle which is 120? Somewhere we
It's
can
a
say it like this.
second quadrant, right?
Yeah, it's in the second quadrant. So this one,
Yeah.
this one is 120, right?
Yeah.
So we are not considered about the figure. We are just finding out the angle because this is 120. Okay, that's very good. But how do you reach to 120? You can from this. Yeah, I told no. This is the primary line. The horizontal line is the primary line, and the
Right.
vertical one is like a secondary line. This is the
Right.
terms which I am giving for you to like uh, so that it will become easier for you because this is a way of my understanding. These are actually not called as primary, secondary, and all. This is just accesses. But to make the process easier, I've been telling like this. So if you want to reach to 120, you can either come from, so what are the different ways in which you can come to 120 degrees, this point? You can either travel from here till here, right? Right, Shreyansh?
Right.
Yeah, or you can travel from 90 to 30, right?
Yeah.
And there's one more way to travel. How to travel?
The other way?
The final, it's not the only final way. There are many ways apart from this, though. But It is an all like repetitive way. The best way to travel is like this. From 180, when you're coming back to this 120, you have to go like 60 degrees, right? 180 minus 60. It's 120.
Right.
And other ways are other like a longer routes. Longer routes are nothing but like coming from 270 to 120, 360 to 120. That is not actually relevant to us and inappropriate at this particular problem.
Mm-hmm.
So the best way to travel is from 180 to 120 or 0 to 120. The reason why I'm telling about this travel is because if you are coming from 180 to 120, you're doing sine of 180 minus 60, right?
Right.
This both means the same. 180 minus 60 is 120.
Yeah.
So anything when you're traveling from the main horizontal line, no? This one you will have to remember always. Sine of 180 minus theta equals sine theta. Sine
Right.
theta. Okay. Sine of whereas sine of 90 plus theta or 90 minus theta, it will be cos theta.
Okay.
So it will lead to lots of confusion. So I always avoid doing this from the secondary line. So I always considered you to travel from the main horizontal line because that is also going to give a easier answer and also straightforward answer rather than you to think more. Correct.
Right.
There won't be interchange of signs. Perfect.
Yeah.
Okay. So what is sine 180 minus 60? It is nothing but, as I told, sine 180 minus theta, sine theta. So this sine 180 minus 60 will be sine 60. Correct. So do you know the value of sine 60 now?
Sine 60 is 3, or is it root 3 over 2, right?
Yeah, root 3 over 2 is the answer. So sine 120 is nothing but the value of sine 60 itself.
Oh, okay.
So now you can easily find out what is sine 120.
Right.
Right. Shall we do
Right.
the same for cos and check out what answer we are going to get?
Yeah.
Yeah.
For cos.
So for cos 120, what is it going to be?
Negative 1 over, or negative 1 over 2.
Yeah, but how do you get? Let's solve that step by step. So you're writing cos
If you
120 as cos 180 minus 60.
Yeah, so for cos 60, it will be 1 over 2. But since cos is negative in the second quadrant, it will be negative 1 over 2.
Yeah, so after writing this step itself, next step when you're writing, you have to write it as cos 60. See, cos 180 minus 60 is cos 60 only. But since this 180 minus 60 is going to lie in second quadrant, so you have to write it as minus cos 60. And what is cos 60? It is 1 over 2. Yeah, perfect. So this is how it's going to be. And it's simpler, right? So the more you practice, more easily you'll be able to remember the thing. And see, tan 120 you'll be getting. What is tan 120?
Tan 120 is tan 180 over tan 180 minus 60. So tan 60 is root 3.
Very good.
Since tan 120 is on the second quadrant, it will be negative root 3, right?
Yeah, perfect. This is how it's going to be. And let us now try to solve. See, yeah, I told you one more thing, no? Sine 90 plus theta also, I could have used that approach to solve this problem. And let's observe what would have happened if I had used that. So you can also travel from sine 90 plus 30, right?
Yeah.
Sine 90 plus theta equals
Sine 90 theta is
negative cos theta.
negative cos theta.
Yeah, because cos is negative in the second quadrant, no? But whatever you're putting, it becomes negative, right, in second quadrant in terms of cos.
Right.
So 90 plus 30 is 120, and again, negative of negative is like, again, positive it becomes.
Right.
Because sine 120, however, you have to get positive only. It becomes minus cos 60, minus of minus is plus, and then you get the answer is, cos 30 itself you get. Negative and negative becomes positive, and you get the answer as root 3 over 2.
Root 3 over 2.
Root 3 over 2. Yeah, sine 90 plus 30, no?
Yeah.
So it becomes negative cos 30, and then negative of negative cos 30 is positive itself, and becomes root 3 over 2.
Okay.
Fine. So that's why this procedure will be leading to lots of confusions and lots of sign changes. So I always prefer doing from the horizontal axis. Okay. So let us now try to solve a problem which is there in the third quadrant. Can you give an angle to it? Can you suggest an angle?
I'm sorry.
Let's now try solving a problem which is located in the third quadrant.
Okay.
So suggest me an angle so that we can try figuring out what is the value.
Okay.
Should we take 225? 225?
Yeah, 225. Yeah, sure.
Okay. So 225 is nothing but this way.
Yeah.
So is this the right way, or is there any better way?
270.
As I told, always make sure. Yeah. As I always told, like make sure you take the shortest route, and also let that route be from the horizontal rather than the vertical.
Right.
So which is a better route?
So.
Can we take from 180 plus 45?
Yeah, sure.
Yeah. So sine of.
Yeah. No, nothing.
Pardon?
Nothing.
Sine of 180 plus 45.
Yeah.
Is nothing but sine of any angle. Like it's not just for sine, it's for any angle. When it is added by 180 degree, it is always positive. It's this one. It returns back the same value.
Right.
So sine 180 plus 45, you get a sine 45, but you should ensure that whether sine is positive or negative in this third quadrant. What is sine in third quadrant?
Sine is negative.
So sine is negative, right?
Right.
So minus sine 45 becomes. So can you tell the value of my sine 45 and
Sine
using a negative
45
sign?
is negative root 2 over 2.
Yeah, super. So for sine 180, sine 225, you got to know, right? For cos, shall we now try with the pi by. See, one more thing I want to say, like 225 degrees. Can you tell it as pi by 4? See, this particular thing is pi, and this will be like pi by 4 in terms of radians. Radians also is very equally important for you to know, and to convert from radians to this particular thing, you can split this up. How do you split this thing into? Like how you split 225 as 180 plus 45?
It would be.
Split up pi by 4 as pi plus something.
Yeah, pi plus pi over 4.
Yeah, with the basic fractions you can do this, right? It's not a problem.
Yeah.
Pi plus pi by 4, and when you take an LCM, it becomes like 4 pi plus pi, that is pi over 4.
Right.
Good?
Yeah.
So sine of pi plus pi by 4. Good?
Yeah.
Okay. So sine of pi plus pi by 4. So what it becomes? It is just becomes sine pi by 4. Negative.
Right.
Because this is 180, right? You should be having that ability to think between this one degrees and radians. You should
Right.
quickly transform and think. So now it becomes negative sine pi by 4.
Right.
So it is same minus root 2 over 2. Pi by 4 is nothing but 45 and becomes sine of 45 is minus root 2 over 2.
Right.
Okay?
Okay.
Yeah. And now shall we do for cos?
Yeah.
Cos of pi by 4. Yeah. So how do you do this?
So it would be cos pi plus pi over 4, right?
Yeah.
And so we have to find cos of, so we have to find negative sine cos sine over 4, then pi over 4.
You're telling this cos of pi plus pi by 4.
Yeah.
Okay, what happens next?
And then we're supposed to find the sine, the cos for negative pi over 4.
Yeah, you're right. Say it confidently.
Right.
Okay. It doesn't get changed, right? This one, the trigonometric function remains the same because you're moving from 180 degrees, so it remains the same.
Right.
Only thing that you should be careful of the sign. Sign also you have taken care. So it is negative cos of pi by 4.
Right.
Okay.
Yeah.
So what is negative cos of pi by 4? It's the same as the minus root 2 over 2.
Right.
Okay. So let's immediately solve for tan of pi by 4. Yeah. Can you solve this?
Okay, so this would be it's 10, 5, or 4 would be 1.
Yeah, very good. So like you can quickly solve it. See, you need not do the steps. Once you are having great practice, you need not solve it step by step. You can mentally you will be able to do it, right?
Yeah.
And this is an easy procedure, right? You are not remembering any other values other than the values which I showed in the start of the class.
Yeah, no.
Yeah, it becomes very simple too. That's good. So let's try solving a problem which is now located in the fourth quadrant. The problem in the fourth quadrant will be like, shall we consider for sine the 330?
Yeah.
So this angle will be like 330 degrees.
Yeah.
Yeah. So 330 is nothing but uh, 330 is nothing but 2 pi minus pi by 3.
Right.
And how do you find out sine 330?
330, it would be 360 minus 30.
Very good. Very good. Very good. See, I expected that you'll be telling some 180, but again, it would be a very long process and you will have to cross. It will become more than 90, right? Again, it is difficult to you. 360 minus 30 is a very good approach. Very good. So you can also say it as 0 minus 30 also. Because sine 360 is also at the 0th point, right?
Right.
However, you'll be getting it as minus sine 30.
Right.
Correct?
Yeah.
Perfect, Shreyans. Very good. Or shall we solve it for 300 because we almost covered 0, 30, 45.
Yeah.
Let's
so,
do for 60. So let's do for 300.
Okay. So 300 would be 360 minus 60.
Yeah. Yeah. So how do you do this?
So you would find so sine in the fourth quadrant is negative, so negative sine 60, and sine 60 is root 3 over 2, and if you put a negative next to it, it would be negative root 3 over 2.
Shreyansh, is it fine? Yeah.
Yeah.
Were you able to hear? Yeah. Sorry, I think the audio got muted all of a sudden. So you got this because he
Yeah.
will be slightly confused, right? Like how to do 5 pi by 3, how will I get the approach, right? So
Yeah.
you can consider it in this way. So 2 pi plus something, it is equal to, it has to be equal to 5 pi by 3. You don't know whether it is x is what, negative or positive. Then finally you have to get the right answer. And also, why you consider 2 pi is nothing but when you divide this pi by 3 as a fraction from the fraction to a decimal, you observe that it is crossing 1.5. The value you're getting is 1.67. So that is beyond 1.5. So it's somewhere here. That means you have to come from the, you have to move from 2 pi itself.
Right.
Right. Right. So 2 pi pi minus pi by 3 is fine to you?
Yeah.
It's same like 360 minus 60?
Yeah.
Okay. So when we are like doing this, what is cos in this particular fourth quadrant? You observe that cos is lying in the fourth quadrant.
Yeah.
So
So
is cos
cos would
positive
be
or negative?
positive. It's positive.
So cos pi by 3, right?
Yeah.
So what is the value of cos pi by 3?
So cos pi by 3 is 1 over 2.
Cos pi by 3 is 1 over 2. So let's do for tan of pi by 3. You're solving it, Shreyansh?
did I? Oh, this would be a negative root 3.
Yeah. Very good.
I'm sorry?
Yeah, very good. That's the way.
Oh, okay.
Negative. Okay. So let's now solve. Uh, let's now solve various problems. Let's now go beyond 360 degrees. Let's see how you'll take this. Like even if you're going beyond 360 degrees, you can have the reference point as the 360 degree line. Like if you're, you need to, whatever we do, you need to bring it back to the most basic quadrant, 4 quadrants, and then from there you can solve it. Okay. You can keep always something in multiples of 180 or 360, and the remaining as the fraction. And the remainder which you get, no? With that thing you can continue it forward. Okay, let me show you one thing. It always breaks down to only that much, right? So whatever you do, it comes down to that. If you want to find sine of 13 pi by 6, so how you do sine of 13 pi by 6?
So sine of 13 pi by 6. So it would be.
You consider first 13 by 6. What value you're getting in terms of decimal?
In terms of decimal, it would be 2.1 over 1.
It's okay. It's okay. Enough.
I think
okay, that's fine. 2.1.
Do we do like 13 pi over 6 minus 2 pi? Because 2 pi is just 12. 12
Yeah.
pi over 60.
So, yeah. So you initial days when you're practicing, you won't know what to add with. So I always say, because you're crossing 2 pi, right?
Yeah.
So 2 pi plus x you get, and that should be equal to 13 pi by 6. So what is the value of x? You can just cross 13 pi by 6 minus. Yeah, that is nothing but x 6 pi by 6. So 2 pi plus pi by 6, no? It becomes.
Yeah.
So this is nothing but equivalent of this is sine of 2 pi plus pi by 6, which is nothing but
1 over 2.
Very good. So it is nothing but sine of pi by 6, right? This 1 over 2. So can you do the same for, let me give you a different angle. Sine of, cosine of 450 degree. 360. No, 480.
480. 480 minus 360 is 120.
So 120 is, how do you approach 120?
So 120 would be 180 minus 60, and cos of 60 is 1 over 2, but since it's in the second quadrant, it's going to be negative 1 over 2.
Yeah, right? Amazing, man. Amazing. Yeah, that's amazing. Very good. So you did it orally, right? Easy.
Yeah.
Child's play, no? The tan 480 in a similar approach.
Yeah.
See, one more thing I could suggest you. See, this one, it becomes like 450, right? So you can say, consider easily like directly 540 minus 480, rather than again saying 360 plus 120 and again saying 180 minus 60. Directly say it like 540 minus 60 is 480 and 60 is nothing but. Just like the way how you used to do for 180, right? 540 is also same as 180 only, no? And this side, on the horizontal axis.
Right, yeah.
Perfect. You're solving it?
Yeah, so I got negative root 3.
Yeah. Okay then. So can we solve for 780? Let's move further.
Okay, 780. That's more than 2 circles. So 780 minus 720, you get 60. So 60. So what are we doing? What's 780? Cos, sine, tan?
Yeah, anything, whichever you want to take.
So
Okay.
sine 780 would be 780 minus 720, which would give you sine 60. Sine 60 is root 3 over 2. Cos 60 is 1 over 2. And tangent 60 is root 3.
Mm-hmm. So what did you do for sine? 780 is it?
780 minus 720.
So what is the final answer you got for sine 780?
Root 3 over 2.
Okay. Very good. So 780 lies in which quadrant?
780 lies in the first quadrant.
Very good. So what next? Can you do for 840?
840. Okay, so 840. So 780 is 60. So 840 would be 60 plus 60. So 120. And so sine of 840 would be root 3 over 2. Cos of 840 would be negative 1 over 2. And tangent of 840 would be negative root 3.
Mm-hmm. Okay. So it is negative root 3 you're saying. Which one? Which is negative? Tan of 840 is negative root 3.
Mm-hmm.
So you're getting this concept, it's easy to follow.
Yeah.
You're getting all the answers right. That's really good. But these concepts are not been taught to you in school, no? Were you aware of these things? Of solving for a higher degree problems?
No.
Mm-hmm. So you're able to learn it quick and fast, right?
Yeah.
It's an easy approach.
Yeah.
So whatever we learn, we make sure that we simplify things in the most easiest possible way and take it step by step, slower and slower. We take it slow and ensure that everything is like perfectly done. Right, Shreyansh?
Right.
Yeah. So let's now try solving something even more higher. 6. Would you like to revise some of the concepts, Kalnav?
No.
Not required.
Yeah.
Mm-hmm. Okay. Okay. Now solve for 19 pi by 3.
19 pi by
19 pi by 3.
Okay, so 19 pi by 3, which would come out to 6.3333 something. So 19 pi by 3 minus 6 pi would give you pi over 3, right?
Yeah.
Yeah, so pi over 3, sine of pi over 3 is root 3 over 2, cos of pi over 3 is 1 over 2, and tangent of pi over 3 is root 3.
Mm-hmm. Yeah, perfect, Shreyansh. So now can you give me a problem from your side? Can you tell a particular number which you want to try solving? Any bigger value?
any bigger value.
So now actually you crossed almost like 3 revolutions of circles, and even then you are getting the answer right. So I think you're fairly very good now. You're extremely good now. And can you tell a particular value for which you think will be challenging for you to solve?
Can't really think of anything right now. I'm not saying I'm not bad at this. I'm just saying I can't think of anything.
Yeah, okay. Like you want to cross 2000 degrees?
Yeah.
2000? Would you like to do for, this will be challenging. Sine 3000?
Sine 3000? Yeah, sure. So sine 3000 would be 360 would be 8 point something. So if it's sine 3000 minus 360 1, 2, 3, 4, 5, 6, 7, 8. So sine 3000 minus 2280 would give you 120. So sine of 3000 would be root 3 over 2. Cos of 3000 would be negative 1 over 2. And tangent of 3000 would be negative root 3.
You're telling me the answer?
Yeah, that was the answer.
Can you tell again?
I said, oh wait, let me look at what I wrote down.
Check. Can you check it out again?
Yeah, so I said sine 3000 would be 3000 minus 2880, which is 8 rotations of an entire circle. And so it gave me sine 120, and sine 120 is root 3 over 2. And cos 120 is negative 1 over 2. And tangent 120 is negative root 3. Right?
Hello, Sriyansh?
Yeah.
So sine of, so try solving for 101 pi over 6.
101 pi over 6. Okay, so
It's just numbers, right? Everything is like getting simplified. So
yeah, 101 pi over 6. 101 pi over 6, if I do that, it is 16.8333. So 10 pi over 6 minus 16 pi, right? Which gives me 5 pi over 6, right?
yeah.
Yeah, so 5 pi over 6, so which is 1 100 and 135. No, 150. So sine 150 is 1 over 2. Cos 150 is negative root 3 over 2. And tangent of 150 is 1 over negative root 3. So root 3 over negative 3.
Very good.
Yeah.
Very good, Shreyansh. So this big value is also able to solve. So you have expertise this one. And in further class, let's see more about the trigonometric identities, trigonometric ratios.
Yeah.
I'll just give you a brief introduction of this particular three unique. These three identities are very important. The most important identity: sin square theta plus cos square theta equals 1.
Right.
Heard of this? Hello.
Huh?
Yeah. Have you heard of this triangle? Sin square theta plus cos square theta equals 1. Anytime?
I mean, I've never heard of it, but I can like see it work, like, because like they're opposites and everything. So.
That's
Right?
good. That's very good. Like you want to see how it works? Like you want to try it out?
I mean, I think I can already kind of tell, because like, um, let's
Because
take
like,
sine 30 and cos 60, right?
no.
No.
Yeah. Take it as sin 30 and 30 itself. Sin
Sine
squared.
30.
What is sin 30?
Sine 30 is 1 over 2.
Yeah. Cos 30?
Cos 30 is root 3 over 3. That's root 3 over 2.
Okay, when you add them up, what happens?
So.
Can you add them up?
Yeah. Give me a second. I got 0.75 for that.
No, what is 1 by 2 the whole step by
1 by
step?
2 the whole square is 1 over 4 plus 3 over 4 equals 1.
Okay. So this always holds good when you are doing sin square theta plus cos square theta equals 1. And let us see like what all we can deduce with this particular equation. Can you divide this equation with respect to cos square theta on both sides?
I'm not sure.
No, just divide and tell me what happens.
So it would be sine squared theta equals cos squared plus 1, right?
Sin square theta by cos square theta.
Oh.
You are dividing both sides by cos square theta. So cos square theta by cos square is 1, right?
1
1 by cos square theta
is
secant square theta.
yeah.
So sin square theta by cos square theta is nothing but tan square theta. So this is one of the another important equation. So secant square theta equals tan square theta plus 1. Correct, Shreyansh?
Yeah.
Okay. So with this particular thing, see, you divided by cos square theta for the first iteration. Can you divide by sin square theta and then tell me what another equation you might be getting?
Wait, I have a question. How is there going to be a plus 1? Doesn't cos squared theta and cos squared theta cancel?
No, it doesn't cancel because here you don't have any in the denominator, right? Because only if you have entirely, it will get cancelled, right? See, sin square theta plus cos square theta equals 1. So you're making sure that you're dividing both sides by cos square theta. So you're doing cos square theta by cos square theta by cos square theta. The originality of the equation remains the same, right?
Yeah.
No changes because cos square can get cancelled because these are like the LCM. So even if you're taking as a whole and then seeing this cos square, then this cos square can get cancelled. But since you are dividing separately, this and this gets cancelled. You put plus 1. The sine square theta, cos square theta, this, it becomes this. And sine square theta by cos square theta is nothing but tan square theta plus 1. So now in this case, you won't be able to like cancel because you have to take the LCM and only then you can cancel, right? If you take the LCM, it becomes like the original equation.
Right.
Perfect.
Yeah.
Okay. Similar to this, if you want to compare it with like when you're dividing it with sine square theta, what would happen to the equation? Like how this equation will modify? Like in this equation, you're going to divide by sine square theta and get one more equation. Similar to this. Just observe properly and say like what changes might happen. Can you divide that equation by sine square theta and say me?
It will be cotangent, right?
Very good.
Cotangent square theta plus 1
Very good.
equals
Equals
cosine? No,
cosine. 1 by sine square theta is cosecant theta, no?
Yeah.
That is cosecant square theta. Good?
Yeah.
Okay. These are the three main equations. So using these three main identities, you will be able to solve any kind of like a trigonometric equation type of problems. All this time you are seeing how to do the values of angles and degrees, and that is not the only part of trigonometry. You'll be like required to like substitute, rearrange the equation, modify slightly, and you'll be asked to like prove that LHS is equal to RHS, something like that, those kind, right?
Right.
Okay, Shreyansh. Did you like the class?
Yeah.
Yeah. You learned something useful?
Yeah, I did. Yeah.
Okay. Any feedbacks or suggestions?
Um,
Or was the class too fast?
no. The class paces are good. It was usually the pace where I go.
Okay. Okay, Shreyansh.
Yeah.
Yeah. Okay then. See you in the next class.
Yeah. See. Bye.
Bye bye.